This video, we're going to talk about higher order derivatives. And by that we mean the second derivative, the third derivative, the fourth derivative, and so on like that. First, we'll talk a little bit about notation, kind of the idea there. We know ways to write our first derivative already. If we're given f of x, we can call our derivative f prime of x. If we're given y, we can call it y prime, or we could also call it dy dx. That's another one of our notations here. Now, the second derivative, to find the second derivative, you just take the derivative of the first derivative. So it's two derivatives in a row, if you will. And what is our notation here? Well, we'll have f double prime of x, or, oh, I forgot to write my prime up there. My bad. Forgot to write my prime originally. So go back and make sure you put your prime there. So again, the second derivative would be y double prime in this case. And then our notation, the dy dx, it's a little different when we start getting to more derivatives, higher derivatives. So we're going to have this. So what you can think of is it's saying it's derivative, take it twice, of the function y. So derivative of y with respect to x both times. That's kind of the idea. Let's keep going. A third derivative would be f triple prime of x, or y triple prime, or we would change those 2's to 3. The fourth derivative, a little bit of change. The little prime marks get to be too much, so what you start doing is putting it in parentheses. So the fourth derivative looks like that, or y to the fourth. It's very important to put it in parentheses so you're distinguishing it. It is not an exponent. It is notation for the fourth derivative there. And the same kind of idea over here. This pattern remains. And then the nth derivative, because theoretically this could keep going forever, right? We could have, the 100th derivative. We just keep taking derivatives of derivatives of derivatives. We would just put an n up there to represent it. Y to the nth derivative, and replace these here as well. All right. Feel free to use the notation you like. I will say that these first two columns are probably a little bit more common here in Cal 1. This last column is super helpful when you get into multivariable stuff and you have to, distinguish what you're taking the derivative of and which variable you're using. All right, so let's go and do some examples. Let's find y double prime for y equals x sine x. So that means we need the second derivative, which means that we need to find the first derivative, and then after that, take its derivative to get the second derivative. So let's start with y prime. Well, as I look back up here, I see that I have two functions multiplied together, so I'm going to have to use the product rule to find the first derivative. So my derivative will be x times the derivative of sine x, which is cosine x, plus derivative of x, which is just a 1, times leaving sine x alone, or x cosine x plus just plain old sine x. I don't really need the 1 there. All right, so what is that? That is y prime, but we've been asked for y double prime, so we'll just take the derivative of the derivative. And as I look, I see that I will need the product rule for that first piece, but the second piece I'm going to be okay. So let's use that product rule again. So x times the derivative of cosine x will be negative sine x, plus derivative of x is a 1, and we leave cosine x alone. Okay, so that was just the product rule. Okay, I did the product rule here. So I've done part of my derivative, but I still need to take the derivative of that sine x. Remember, we got to finish our sum here. So the derivative of sine x is cosine x. And now I do want to take a moment to clean things up. So I have negative x sine x here. Clean that up a little bit. And then I look, that's going to be a cosine x, and I have another one, so it's going to be plus 2 cosine x. General rule of thumb, you should clean up any constants and combine any like terms. All right, let's do another example. This one is asking for the fourth derivative of a function. So to get the fourth derivative, we first need the first derivative, the second derivative, and the third derivative. So let's get going. This is just a polynomial, so it's going to be pretty straightforward with our power rules and our constant multiple rules. So f prime of x looks like it'll be 30x to the fourth minus 6x squared. Remember the derivative of 5 is a constant, so its derivative is 0. Now I'll do f double prime. Remember that means the derivative of the first derivative. So what do we get? 120x cubed minus 12x. Okay. Now we'll just keep going. We get f triple prime. What will that be? 3 times 120 is 360x now squared minus 12. So there is f triple prime, the third derivative. And now we can get that fourth derivative like we've been asked for. And what do we get? 2 times 360, that's 720x. And there we are. I think we're done. Okay. There is our fourth derivative. All right. Let's do another example. Let's find y triple prime for y equals 2x to the 3/4 power. So y prime, we can just use the constant multiple rule and the power rule here, will be what? 2 times 3/4 x. And now I need to subtract 1. If I subtract 1 from that, I get a negative 1/4. And I'm going to take a moment and clean this up just a little bit before I keep going for my next derivative. That'll end up being what? 3/2 x to the negative 1/4 when I simplify those constants. So now let's find y double prime. Multiplying again, we'll have 3/2 times a negative 1/4. You can do that together. Go ahead and do it, or you can write them out and multiply later. It's up to you. X, now I need to subtract 1, so I'll be at negative 5/4 now. Think about subtracting 4/4 from the negative 1/4. And we'll take a step to clean up, negative 3/8 x to the negative 5/4. And then one more time, y triple prime, negative 3/8 times negative 5/4 times x to the negative 9/4. And again, clean up, 15 over 32 x to the negative 9/4. And there is our third derivative. So the basic idea, we could take one derivative. All of our rules just stay the same. If you need a second derivative, you just use the same rules and take the derivative of the derivative, and you just keep going. But that's how we handle higher order derivatives.